Hello, so in the last video we were trying to look at this question. It was also to do with like fertilizer and stuff and inverted cones. We basically showed that this was true. Now I didn't point this out in the last video, so I'll point it out now. This is something called a differential equation. Now what is a differential equation? It sounds quite scary, but it's honestly not. If I just write down an ordinary equation like y equals x squared plus 4, for example, okay, that would be an example of an equation, okay? You've got something on one side and something on the other, and the thing which connects the two is an equal, so we call it an equation. Okay, well if I think about this equation as a function, so in other words, if this was like a function, I'm just calling it y, okay, then I can also differentiate it, so we can have like something like dy by dx, okay, in this case it would be 2x, okay, and then I can carry on differentiating like d root d2 by dx squared is equal to 2, and then carry on differentiating like that, and I get 0 for the next one, okay. Well basically, a differential equation takes each of these, so like a function and the derivatives of its function, and puts them together into one equation. So for example, it might be something like 3 d2y by dx squared plus 4 dy by dx plus 3y, for example, and basically this is called a differential equation. It's an equation, so I've got one thing on one side is equal to the other side, involving derivatives, so it's function and the derivatives of that function, okay? So if I'm finding a solution to this differential equation, then what I'm basically finding is, what is the function that satisfies this equation? So what is the function which, when I differentiate it, so what is the function when I times it by 3, I differentiate it times by 4, differentiate again times by 3, it comes out as 0. What is that function? That's what I mean by solving a differential equation. That's what a differential equation is. Okay, well would you be happy that what I've got up here, this h squared times dh by dt minus 900 over pi, is just a differential equation? Because h is a bit like my function, so I square it, okay, then I times it by the derivative of that function, okay, then it's just equal to some number on the right hand side, okay, so this number on this thing on the right hand side, it's minus 9 divided by 400 pi, that's going to come out as a number, okay, so it's just a number, just treat it as like a number, okay, but look, it's a differential equation because I've got h, that's my function, and I've got the derivative of my function, okay, kind of combined together into an equation. So that's called a differential equation. I mean, there are other types of things like ordinary differential equations and partial differential equations. It's called an ordinary differential equation because it's only a function of one variable. H is only a function of one variable. If it's a function of more than one variable, a partial differential equation. I mean, it's a first order differential equation because the highest derivative is 4. Is the first one, sorry. So yeah, you can kind of put some language on it, but basically this is a differential equation. That's the most important thing. Now, the way which you look at solving differential equations in this course, there's only one way you look to solve it. There are other ways, and it can get quite messy if you're interested in it. But basically, there's only one way, and it's called separation of variables. So what that means is that you treat this dh by dt as like something involving h over something involving t, treat it like a fraction, okay? And then you basically just try and separate them up. So you try and separate all the stuff involving h on one side and all the stuff involving t on the other. So let's look at this. Well, at the moment, I've got an h here and I've got a dh here. So those are kind of together, that's fine, okay? On the right-hand side, I've got nothing involving h, so okay, I'm happy days. But unfortunately, on the left-hand side, I've still got something involving t. So I want to try and remove that. So basically, what I'm going to do is I'm going to treat this as a fraction, and I'm going to multiply through by dt. So I'm going to put the dt up here. So I've got h squared times dh is equal to negative 9 over 400 pi. Remember, that's just a number, times dt, okay? Well, look at this. This is a little bit kind of like a mathematical fudge, but it totally works. This almost looks like an integration. If I stick like an integration sign there and an integration sign there, then that just becomes an integration. Because look, I've got the integral of h squared with respect to h, that looks exactly like an integration, and the same thing over there, the integral of some number times with respect to t, okay? So basically that's an integration. We say we integrate both sides, okay? But that's literally what we're doing, it's an integration, and then we just go ahead and integrate both sides. So, well, what's the integral of the left-hand side? Well, we raise the power by 1, and we divide by that new power, okay? And then what's the integral of the right-hand side? Remember the minus 900, the minus 9 over 400 pi is just a number. Don't worry too much about it. So it's a bit like saying, what is the integral of, say, like 4 with respect to t? Well, that's obviously just going to be 4t. So it's exactly the same thing. It's just this number is a little bit more awkward. Okay, so it's times t, okay? And then don't forget your constant of integration. Now, notice I didn't put a constant of integration on this side as well. The reason being is because because a constant of integration is just a number, okay? So if I take this number over the other side and combine it with this number over here, then they're kind of going to be squashed together anyway. Say if like, this was like plus 3 and this was like plus 4, basically. I'd take the plus 3 over the other side, take the plus 3 over the other side, and I'll just be left with plus 1, okay? So that basically just becomes a new constant of integration, okay? So it's just a number, constant of integration, just a number, so I kind of combine them all together as we go. Okay, great. Now, I've been asked to express h in terms of t. Okay. So basically, I just want to rearrange this just to get h on its own. So let's first of all times through by 3. So I've got h cubed equals, well, this is minus 9 times 3 is 27 over 400 pi. I'm just literally timesing through by 3, okay, plus, again, that's 3c, okay, which is just going to be another number. 3 times a number is just going to be another number. So I can carry on calling it c, or you can call it k or whatever. I'm just going to leave it as c for the moment. I'm just simply saying this is just some general number, okay. And then I'll just take this cubed root, okay, so take the cubed root of both sides, minus 27 over 400 pi, times t plus c. Okay, this is fine. This is something called a general solution. Like, I'm basically saying that my function, which satisfies this differential equation up here, is this. But it's called a general solution because I don't know what this number is here. So basically, if I draw this on a graph, I can have, like, I don't know what the cube root graph looks like. So say if the cube root graph looks like that, for example, I don't know. Okay, well, I could also have this one, or I could also have this one, or this one. We call that a family of curves. So basically, it's a general solution because I've still got a plus c. If I want a particular solution, I simply say, can I find the value of c? Well, yes, I can. I have to look back at the original question, and I kind of have to interpret it. And basically, if you look at this, I need a relationship. So I need to know a value of h and a value of t. I can then sub them in, and then I can work out what c actually is. So let's look back at the original question. So I've got that... Hang on a minute, let's read the first sentence. So a container in the shape of an inverted cone of radius 3 meters and vertical height, that's using one of the things in my function, is initially filled with liquid fertilizer. So I know the volume, or the height of the liquid fertilizer, which is what this is, height of the liquid fertilizer at some time t, okay, is initially, so at the start, t equals 0. So basically, when t equals 0, the height is 4.5. Does that make sense? So the amount of fertilizer at the start, so when t equals 0, the height is 4.5. Okay, so I just need to sub this back into here. So, okay, let's have a look at this then. So I've got 4.5. I just simply replace h with 4.5 is equal to the cubed root. Well, anything times 0, because t is 0, remember? So anything times 0 is just 0. So that first term is just going to become 0. Plus c. Okay, so basically what I'm left with there is that the cubed root of the thing which I want to find is equal to 4.5. So I just find that c, stick it into a calculator, and I find that c is just 4.5 cubed. Okay, reverse that, and that just becomes as 729 over 8. I mean, you could stick that as like a decimal or whatever, but I'm going to leave it as a fraction like that. Okay, so basically my particular solution is just that, but I just replace c with 729. So basically, if you want over 8, so if you want to basically find the value of the constant of integration, you look back for the question and you look for clues in the question. You try and find a value two values that you need. So in this case, we wanted to link h and t together. So we find a value of h and a value of t that will basically link those things together, and you're basically then able to find out what c is. That's not too bad.